Hiya. In this video, I wanted to quickly tell you about some practical applications of devShells in NixOS. Now, since it's a NixOS video, I expect you to kind of know already all of the prerequisite knowledge, at least what a home manager is or what a flake is, right? If you don't, I recommend you to consult the Vimjar channel, for example. I personally learned a lot from him. But anyways, um, what are shells or dev shells in NixOS? I would say they are pretty much essential, and you've already met them if you have worked with Nix. They usually contain like a call to make shell, and you supply some packages that you need for the reproducible build environment, right? You probably have some custom targets, supply shell hooks, and environment variables. But I would argue that the same idea of reproducible environment for builds could be extended to a reproducible development environment. What I mean by that, I would like to show you some C++ project. It's basically a OpenGL wrapper. Now, on my host machine, I don't have Clang or GCC or CMake installed, right? And if I go inside of my C++ file, no LSP would start, right? I wouldn't have documentation or complete suggestions. Now, if I were to enable the dev shell that I have described in my configuration, now I have GCC, right, CMake and stuff. But most importantly, the LSP is also installed, and some important configurations for C++ also work. For example, I can switch between header and source file, right? This behavior is not described in my host configuration. It's only described in my development shell configuration for NixVim. Now, what it takes to make this work? First of all, I recommend to consult the make derivation and make shell documentation in Nix docs. It the documentation is pretty rough and spread out across several articles in their docs, but there is a GitHub topic which essentially collects all of the needed knowledge. The way I handle my NeoVim configuration is through NixVim, and it gives several ways on how to install NixVim on your system, like for example as a NixOS or a home module, but also you can install it standalone, which essentially allows you to create a package with all of your NeoVim configuration. Now, how did I do it? Well, first of all, I have my components. This is pretty much like a typical NixVim or NeoVim configuration, right? You have some plugins, some settings. That's not really relevant. What's relevant is that I use these components both in my home manager configuration and as a standalone like it's done in the docs, I create a package, right? Now, in the development shells, I have a separate field with components I want to install additionally into NixVim. And what I essentially do is add this standalone package to build inputs in the dev shell. But otherwise, the idea is pretty much the same. You just call make shell, supply needed packages, set up environment variables, and that's it. Now, there are several perks with this approach. First of all, it reduces the amount of toolchains you need to install to roll out your configuration. For example, I have here like Haskell or JavaScript or Rust, right? Rust is pretty heavy, so I wouldn't want to install it on every machine I am managing, right? And on my Raspberry Pi that hosts a main server, I essentially stripped down the installation of the NeoVim and all of the packages I need on the machine to basically none. I only have Java installed here, right? Which is pretty powerful. Initially, the setup was pretty rough. It took me a couple hours, and now it's reduced to only 30 minutes. All of the NixOS rebuild and home manager switch, they both work really fast now. Not only that, if I ever had conflicting configurations in my NeoVim or in the packages I am installing, they would be also sandboxed, right? Because as soon as I switch between development shells, I do not inherit whatever was in the shell before, which is great. Now, I showed you, for example, my C++ project. If we go into my Erlang, which is essentially a Gleam project, you would see pretty much the same behavior. Let's see. I have a Gleam file here, right? All of the documentation works, going to definition works, and if we would look into the running LSP clients, we have a Gleam LSP server here, right? That's it. So this is it. Thank you for watching. Use development shells and integrate your development environments into them. I'm personally very pleased with this solution because I was able to experiment more. As you can see, like different languages, different tool chains and stuff. So highly recommend. Bye.